Hello astrophotographers, welcome back to WandererAstro's channel. Before we get started, let me ask you a question. Looking at this diffraction spike pattern, can you tell me what kind of telescope captured it? We actually posted this picture on our Facebook 2 weeks ago, and most people thought that it's from a Newtonian telescope, and others thought that it's from an RC telescope. But what if I tell you that it's captured by a RASA 11? That's right, after our previous video of Take RASA Further Part 1, today we are back with Part 2. But unlike the Wanderer filter cube introduced in the previous video, which is only compatible with RASA 11 and RASA 36, the new product we are introducing today is compatible with both RASA and HyperStar system from 6 inches to 14 inches. Today, we are introducing the world's first cable-free solution for prime focus telescopes like HyperStar and RASA. It delivers unprecedented diffraction spike quality as well as improved imaging quality. It supports non-destructive installation and removal and is compatible with dual shoot. Also, it provides 2 versions, a cross-spike version and a spike-free version. So what's the problem with the traditional RASA and HyperStar systems? Because the camera is installed in front of the telescope, you have to route the USB and DC cables in front of the telescopes. But unlike the straight spider vanes on a Newtonian or on an RC telescope, the cables are flexible. They can bend, twist, and change the shapes when the telescope points to different targets. So the result is irregular and ugly diffractions. We know that a lot of people try to solve this problem using like 3D printed cable brackets, but those brackets introduces their own problems. A lot of brackets require you to fix the cables using small cable ties. However, those small cable ties also introduce unnecessary diffraction spikes and artifacts. If you want a completely smooth shape of the bracket, we know that for common USB and DC cable, its diameter is at least 4 or 5 millimeters. If you want to create a completely smooth bracket, the bracket should be wider than the cable itself. So once you need to build a bracket that is wider than the cable, the diameter or the width of the bracket will be at least 6 or 8 millimeters. This is a lot of obstruction for RASA telescope, and also the wider the obstruction, the lower the sharpness of your image. And the things get worse when you are installing a Wanderer filter cube, because it's an electronic filter wheel. You have another USB cable if you have cameras without the USB hubs, like the QHY-CCD cameras. You have an additional cables, and it makes things worse. So we started thinking differently. Instead of organizing the cables with the bracket, why not just make the bracket become the cable? Once we have that idea, the solution becomes obvious. We use a specially designed PCB and put it in front of the telescope. The 12-volt power and the USB data is routed on the PCB, and we moved all the USB and the 12-volt connectors to locations that is outside the optical path of the telescope, like it's here and it's here. So the result is the only thing in front of the optical path is this thin PCB, and there are no more cables crossing in front of your telescope. And this gives us a huge advantage because, we can manufacture the PCB very precisely, so we can adjust the diffraction spike we want as we change the shape and the thickness of the PCB. And that's why we provide 2 versions. One is the cross-spike version, and the other is a spike-free version. For cross-spike version, it uses two PCB vanes arranged in a cross pattern. The PCB itself is only 1.6 millimeters thick, so compared to traditional brackets, which is often like 6 or 8 millimeters thick, it can provide much sharper diffraction spikes. For your comparison, the spider vane on a Takahashi Epsilon is around 2 millimeters thick. So in theory, our design is capable of producing diffraction spikes that is comparable to a Newtonian telescope, and this is exactly what we found in real imaging. You can take a look at these images. If we showed them without the context, most people would never believe that these pictures are captured with a RASA. Yet every one of these examples was taken using our diffraction spike system. But hold on, although this design now looks very simple, but in fact, it requires a tremendous amount of engineering behind it. We spent countless nights testing, imaging, and refining the design. The goal was not just creating diffraction spikes, the goal was creating beautiful diffraction spikes without any artifacts and any reflections. If you look at it closely, you will find that it's not a simple PCB. In addition to the black color, we developed a carbon fiber light baffle at the leading edge of the vane. You will notice this small T-shaped structure, and this structure helps you to control the length of the spikes and suppress the reflections, and helps you to avoid any unwanted artifacts from bright stars near the edge of the field. The result is a clean and elegant diffraction pattern that rivals what you'd expect from a premium Newtonian telescope. And we also have the spike-free version. You can see that it has an S-shaped design. It can help your RASA to get rid of any unwanted diffractions. For our cable master for RASA 11 and 36, as well as the HyperStar 11 and 14, we provide one USB 3 and two USB 2, and also a 12-volt connector. And for the spike-free version, we have one USB 3 and one USB 2 and a 12-volt connector. And if you are using the cable master for RASA 6, RASA 8, as well as the HyperStar 6 and HyperStar 8, we provide only USB 2 connectors, because you won't use the full-frame cameras on RASA 6 and RASA 8, right? And the installation is also very simple. We will make a separate video about it later. You only need to stick the bracket on your telescope, and it is very sturdy. You can see that I can even move the whole telescope holding our bracket, so you don't need to worry about its stiffness. And you can see that we also have a bracket in the center, which helps you to organize your cable. You can just like this. It helps you to organize your cable so that your cable does not enter the optical path. Okay? There are also some slots on our bracket so that you can adjust the position of the PCB in case that the two spikes are not strictly perpendicular to each other. So we have prepared everything for you, including these shorter USB cables and this USB cable, male-to-male USB cable that is used to connect our cable master to your PC. These are also included in our packages. And in addition, in our package, we provide two different lenses brackets for each model to accommodate cameras with different lenses and to accommodate the difference between the RASA and the HyperStar, because you know the HyperStar has more protrusion here. So we have considered everything for you, and I hope that our Wanderer Cable Master can take your RASA or HyperStar imaging to the next level. So that's all for today's video. Thank you for your watching. See you next time.